Good evening, everyone. Today you are going to witness the presentation of our group for our study entitled Development of Typhoon Resilient, Phototrophic, and Self-Storing Solar Panel System, or TRESPUS. This is presented to you by the researchers
Bonto,
Christine Borlagdan,
Latrell Cimanes,
Castel V,
and Olaguera.
with our advisor, Engineer Darwin M. Murillo, PM.
we have the overview, the major section of this thesis defense presentation. We have the introduction, problem, literary review, theoretical framework, objectives, hypothesis, methodology, implementation, results, analysis, conclusion, recommendation, and references. And for our introduction, non-renewable energy sources are one of the major sources of pollution that destroys the environment, which amplifies climate change. Solar energy is one of the most promising energy sources, which gradually grows in recent years. The development of type resilient and self-storing phototrophic solar panel system, or TRESPUS, is inspired by phototropism from plants, which provides adequate charging and lighting capabilities for most electrical devices. This study aims to create a device that can be utilized for the advancement of Albay in terms of using renewable energy. And for the problem, number one is the what is the design of a mechanical and automatic self-tracking solar panel with self-storing mechanism. And the next one is how to determine a performance of the device in terms of amount of electricity stored versus conventional solar panel system, or the tolerance against environmental conditions. And the third problem is what is the significant difference between versus the conventional solar panel system in terms of A, functionality, B, safety, C, efficiency. And for the last problem is that what is the cost benefit analysis of the type of resilient surface storage phototropic solar panel system, which is TRESPUS. Problem. The existing design solar tracker available in the market allow the panels to maximize the amount of the energy that can harness from the sun. However, most of these commercial solar panels, which solar trackers are to be more at risk than most existing fixed panels due to its moving parts, which are prone to destruction during harsh weather conditions such as the typhoon. Hypothesis. No, there is no significant variation on the device performance. Alternative, this is a significant variation on the device performance.
So, for the objectives of the study, this study was conducted for the following purposes. Number one, to utilize the phototropism in plants in designing a solar tracking solar panel system. So, two, to design a mechanism similar to the movement of makahiya leaves that closes when exposed to a certain condition to act as a self-storage mechanism. So, three, to determine the performance of the device in comparison to fixed mounted solar panels. Number four, to determine the effectiveness of the device in terms of harnessing energy from the sun. And number five, to determine the capability of the device to withstand harsh weather conditions such as typhoons and strong winds. So for the scope and the limitation, it bounds only to proving whether the device is one, capable of following the sun's location or direction. Two, able to automatically function during night and day. Three, able to store the solar energy harnessed from the sun in the form of electricity using a battery. So four, determining the relative effectiveness of self-storage mechanism against certain environmental conditions. So, in this premise, the amount of energy lost from friction is not included in the study. So, next, significance of the study. The study has a great impact to the following: nature, sidewalk, lighting systems, and roadways. So since Philippines is a typhoon-prone country, this is a very great help to mitigate and to um, what's
Mitigate, mitigate.
reduce the reduce the destruction of solar panels in the Philippines. So for schools, offices, and government facilities, this is important for producing new solar panels here in, especially here in Albay, since this is also one of the most typhoon prone province. So for home improvement and electrical installation. So this is for retail persons. Then for researchers and innovators. For researchers and innovators, they are able to study and use this study for as a basis for future references in solar tracking and self-storage mechanism, which is only available currently on cars and other stuffs, not yet on solar mechanisms.
So for the review of related literature and studies, so according to Imtiaz et al. 2020, solar energy is a promising sustainable power source asset. If the solar panels have an opposite profile to the beams of the sun, it will create more vitality. The objective of the work is to track the sun so that the rays of sun will always be in perpendicular with panel. As the cost of manufacturing the solar tracking setup is high, there are alternative less expensive choices that have been proposed. Another review of related literature, according to Jadav P. et al., year 2019, light-dependent resistors, or LDR, is used in solar tracking system to track sun, which precisely controls the mechanism. This system can increase the proficiency if the board is not adjusted, improvement of yield by 30% and 60% than the stationary framework is conceivable by the following framework. According to the use of single-axis tracking can increase the electricity yield by as much as 27 to 32%. Review of another is by Mackenzie. Mackenzie stated that solar trackers are unique solar racking and mounting devices that offer higher efficiency than their standard model counterparts. Generally, a solar tracker will make a solar panel around 40% more efficient. Depending on your goals, that means you can use a 40% fewer panels to generate the same amount of electricity, or you can use the same number of panels to generate 40% more. The relay module or interface board contains sets of binary actuators that behave as an electrically operated switch called relay, where each relay in the system is used to handle one load running on alternating current, having a maximum voltage of 220 volts, according to Martur and Calvante. Moreover, Borkar et al. Stated that relays are switches that controls the opening and closing of the circuit contacts of an electronic circuit. For the microprocessors, these are integrated circuits which process the instructions in a computer program, perform calculations, and send data to and from memory and disk. Arduino is an open source hardware or software programming platform based around Atmel microcontrollers. Inclined with the studies, the researchers utilized the existing solar tracking mechanisms and the self-storage mechanism of Makahiya plant to build the device. There are a couple of disadvantages that came along with the solar tracker's unique model. First, they cost more to produce and install. Second, they do require more upkeep. Still, even with those extra costs in mind, solar trackers are more cost efficient overall and are better long-term investment than their stationary counterparts. So, a study conducted by Del Rosario in 2014 stated that the solar is still relatively inexpensive, low technology system, especially useful in the rural and remote communities of the developing countries, especially in the regions of Mindanao. They proved that the solar trackers can add to the productivity of harnessing the sunlight in terms of cost and size, saving as well as the number of solar energy gains. The result of the two test subjects carried out provides the necessary comparison between the fixed and auto tracker. So the figure presented compares the fixed panel versus the tracking panel. So the power, the data is recorded
showing
show,
showing power
showing the power
harness.
and harness from time to time. So there's a 1 hour parang interval of measuring the power by the fixed panel and the tracking panel. So a study conducted by Andres intended to link the gap between the presently available technology to small-scale consumers and the integration of both solar tracking and concentrating photovoltaic CPV into a PV module to harness more power. The error in the inclination angles were found to be minimal. The increase in power output was significant, and the device has an annual return of investment of 17.04% within a payback period of 5.83 years. Synthesis of the state of the art and gaps bridged by the study. So according to the related literature that we had gathered, the design of the solar panels had been actively being used, but only few or several companies. And at the same time, the inability of these solar panels to protect itself against natural environmental conditions such as rain and typhoons had always been the reason for it to not be generally accepted and used across many countries, along with facilities and or building or premises. Most of the time, these designs are mostly used by only few companies who are mostly located at countries with less rains and no occurrence of typhoons where the sun shines bright. Philippines, on the other hand, had the same climate. However, the big difference is with the presence of natural environmental occurrences such as typhoons and heavy rains. So this led us, the researchers, to make a more efficient, cost-effective solar tracking solar panel system that has the ability to store itself specifically during night and during the occurrence of environmental scenarios such as typhoons and heavy rains. The invention of the device and testing its performance in both simulated and actual environment was the main goal of the study. Gaps.
So that's bridge. So gaps bridged by the study. As many devices of the same function of solar panels available in the market, still this specific technology is fully not accepted and used thoroughly by the public. Especially in some locations, most common solar panels are placed once the sun changes its angle. The solar panel will get harness lesser energy as well. At the same time, as most of the technology revolving behind solar tracking requires programming skills and the use of some circuit boards and electronics, it proved harder for the public to get access to them or buy them. They are not readily available in the market as well, making it quite unpopular, and the current solar panel system available do not have a self-storage mechanism. At times of natural calamities and or environmental scenarios such as rains, these panels are easily destroyed or damaged. This study broadens the scope of solar energy technology and would like to set up a newer standards which affordable against most commercially available products. The researchers seek that the device be cost effective, affordable to every Filipino community who would like to utilize this technology and for more ease of access. So, theoretical paradigm. The theoretical paradigm guides the research throughout by providing a general representation between things in a given phenomenon stated within the grasp of the study. The paradigm of this study is illustrated above. So that's the theoretical paradigm. Before proceeding to the process of the study, it is taken into consideration that the design criteria will be the first to support the computation and the different systems of the device's design, such as tracker and mechanical parts. For the process of the study, design plan and circuitry system will be needed to compute and analyze the structural design. Mechanical system analysis is needed to determine the proper movements needed in order for the device to execute proper automatic self-storage. Solar tracker perspective. Most solar trackers involve singular moving panel in the same direction. Thus, the researchers decided to modify this system by following a set of commands and patterns which is programmed by Arduino and self-storage mechanism. The device is built with sensors, and when the sensors are triggered, it would send signals that would execute certain commands that allows the arm of the device to move the panel. When both sensors acquire similar readings, the device will stop the motion. Upon reading and designing the device, the study would be basing the design from existing solar tracker mechanisms that is already available in the past studies incorporating the data of how a makahiyak plant falls inward as a defense mechanism. Solar panels protect itself against natural environmental conditions such as rain, snow, typhoons, and it is integrated using the principles of programming. So, programming principles. The principles of programming are essential knowledge that every program should know. These principles will lead to creating a clean and modular design that will be easy to test, develop, and maintain in the future. In this study, programming language used is C double plus in order to program the Arduino board. The total cost estimate of the project is needed and important to come up with a successful completion device together with its appropriate design features. Next is the conceptual framework. The main focus of the study is to design an efficient solar panel with solar tracking system and self-storage mechanism features. There are several processes to achieve this goal, and the first step is the solar tracking and self-storage perspective. In solar tracking, create a prototype and design plan to achieve initial design of the solar tracking system, while in self-storage, consideration of the mechanical processes and solar tracking mechanism to match the design. Then, synthesize both parameters to achieve a target design and proceed evaluation for several tests of safety and workability. Lastly, adjustment of parts to achieve the best design of the device.
So, let's go now to the methodology or the process on how we built the Trespass or self Typhoon resilient self-storing phototrophic solar panel system or Trespass. So, for our quantitative method, so we have set several parameters in order for us to guide throughout the development of the device in our study. So our first parameter is one, design of the automatic single-axis mechanical self-storage system. So by meaning of the single-axis system, it moves only on a single axis. So let's say from x-axis, it would only move from that direction. In accord in accordance to other designs, one of the most available designs as of today are the dual axis, or those that directly move into two axes, the x and y axis, or y and z axis, in order to track the specific location of the sun. In this case, we are using a single axis mechanism for our design of the self-storage system of the solar panel system. Our next parameter is the design of the sun tracker circuit. So the sun tracker is the one of the most important parts of our design, as it would serve as the heart of our uh, study and our device, since it would give us the ability in order to track the location of the sun in order to produce our projected or expected amount of energy harnessed from the sun, which in turn might match or surpass the amount being produced by fixed mounted panels in theory. Our third parameter is, of course, the experimentation, comparison, and recording various results. It is important that we test the capabilities of the device, its performance, and to record all of the necessary information that we are able to see in conducting the experiment, in order for us to determine what the things the device can do, what are the device's weakness, and what are the things we need or we might need to do in order to improve it. So in our data collection procedures, there are several experiments that is conducted. Now, for that, we, the researchers, used four experimental tests to determine the performance of the device, which are the following. Number one is the simulated test. In this test, we are going to simulate. We are going to do some simulations, or to simulate events in which the device might encounter. So, for example, the typhoon, since typhoon does not, you cannot control typhoon, or you cannot create a typhoon. We did a simulation test in order to achieve the same characteristics, same on that type, or the specific typhoon, such as the wind speed, in order to test the capabilities of the device. Actual environment test, or the actual exposure to the environment. So of course, since simulated experiments are from the term simulated, which is artificially or man-made, so of course there might be a difference when it is exposed to real-time or actual environmental test. That is why we included the actual environment test in order for us to determine the capabilities, the efficiency, and the performance of the device in real-world or real-time situation. The next one is the very specific wind tunnel simulation test. As we all know, there is the wind tunnel simulation is a type of simulation uh, used by several researchers and companies that involves wind tunnels. Currently, there is no available wind tunnel here in Albay, so we decided to simulate or replicate its functionalities by doing several experimentations and improvisations, by utilizing the materials that are present in our community. The next one is the comparison test. It is important for us to compare the performance of our device into pre-existing technologies or devices that is similar to our own device. By that, we are able to determine what are the things we need to improve on and what are the things we need to change, or what are the things we need to look into when developing an improvement, or doing a repair on our device. So here you can see the block diagram of the solar panel system. So you can see here the solar panel, the charge controller, battery, servo motor, electrical current circuit, photosensor, and LDR. So first is the solar panel. When the solar panel is hit by the is directly hit by the rays of the sun, so it generates an energy, and it creates a current as it passes through the photovoltaic cells, which goes to the charge controller, then goes to the battery, and the battery is charged. At the same time, the battery supplies the energy in order for the charge controller to work. Then it will go to the electrical current control circuit, in which the electrical control circuit has photosensors or LDR. Photosensors or LDR, the LDR means light dependent resistors, and these are photosensitive or light sensitive resistors that once hit by light, it reacts to it, creating a resistance. So these resistances produced by the LDR or the photosensors emit several signals that we can utilize in order to uh, create readings, and those readings will have specific types of commands that can execute the different functionalities of the device. So, for example, when the photosensors or LDR is hit by light, it creates signals by the use of the resistances it creates. These resistances or readings will go to the electrical control circuit. The electrical control circuits reads those information, and when it reads those information, it executes commands based on its readings. When they do that, it sends another signal to our servo motor, in which the servo motors provide the mechanical power needed in order to tilt the angle of the solar panels. By tilting the angle of the solar panels, we are targeting the azimuth of the sun, in which the panels is directly perpendicular to the rays of the sun, in which, in theory, the solar panels get more energy when it is perpendicular or facing directly to the rays of the sun. So when that happens, the solar panel is hit again by the light, and the block diagram repeats itself. So the system is a continuous loop as long as all the parts of the device is functioning. Now, yeah. So let us go now to the design of our device. So you can see here the different views and different parts of the design. One of the designs which you can see here is the orthographic view of the panel arm. The panel arm is the part of the device that holds the solar panels and is the movable part of the system. So this is the part of the device that moves and follows the rays of the sun, on which they are, or which it is located. The next one you can see below that is the orthographic and isometric view of the power supply chassis. Since it is important for us to, of course, harness energy, those energy that is harnessed by the solar panels are needed to be stored. So what do we need in order to store those energy? Batteries. And we are using lithium polymer batteries or rechargeable lithium ion batteries that is readily available to market. So in this design, you can see here that uh, it is designed in in a fa- in a fashion that it is able to provide or supply the sufficient amount of current needed by the device to operate itself. Okay. And next is the orthographic and isometric view of the servo motor. Servo motors are types of motors that can be commanded by several control programs. So these servo motors, unlike other motors, have what we call actuators. These actuators read specific amount of information that enables it to make the motor to move uh, very specific, especially in terms of angle, in number of rotations, and of course by speed and many other factors. So the servo motor serves as our device main mechanism in order for it to move. So these servo motors are interconnected with our panel arms, in which the servo motor will execute the push or the pull needed in order for our panels to move on its own. So below that, you can see here is the schematic diagram of the Arduino Uno. We used Arduino Uno R3 in order to program the device, in which it would execute and read all the sensor information given by the LDR or solar sensors, in which it will also read and execute commands that will be sent to our servo motor to execute actions needed by the device in order to track the location of the sun. Now you can see here the full setup of our device. So you can see here the device full setup, the different views, and how it is built. So in order to develop these designs, we use AutoCAD in order to specifically do some calculated measurements in order to achieve the best possible design, simple design for our device. So you can see here from the left, you can see here the actual development of the device. On the left is the original manuscript, uh, read from the paper. At first, we decided, of course, since our study is new and fresh, we are designing a fully functional solar panel system. We need to create a specific design that would fit several requirements needed for it to function. Now, how do we do that? The first thing that we do is we utilize the use of solar panels that are available in the market. Now, since we have the solar panels, we are able to create uh, and develop some measurements that might or will fit the current materials that we currently have, and that is the solar panels. From that, using our original manuscript written on pen, on our paper written by pen, so we created and measured using our basic tools such as rulers, and we hand drawn them into designing the uh, first prototype of the device. We use reverse engineering in order to draw them and to create or in order to create the design of the device. After that, by using recyclable materials, we use boxes, cartons, and popsicle sticks in order to create the first phase of the device. Now that we are able to successfully develop the very first prototype of the device, and when we are able to, and as soon as we are able to determine and decide that it fits the requirements needed in order for the solar panels to be placed on the device, we now decided to use these findings by using the measurements that we had developed on our very first prototype. We added it into AutoCAD, which is a computer-aided drafting device. I mean, a program used to design. Uh, by that, we used AutoCAD to draw the exact sizes for us to produce the exact design of the device using a 3D printer. We used Ender 3 Pro 3D printer in order to print the exact size of our device uh, in which is aligned to the design that we created. So for the actual makeup device, you can see here that we are using CAD reading software or 3D modeling software. And at the same time, at this image, you can see the different wiring system that is based on our uh, actual design of the circuitry. So upon doing that, and upon doing so, and upon printing those materials using PLA or polylactic acid, uh, and a plastic material that is inter being used as a filament for 3D printing, we 3D printed those several parts which are mentioned earlier, such as the arms, the body, and other parts of the device in order to create that and assemble it in a form that you can see right before your screen, which is the actual device. Now you can see here the analysis of our experiments when we conducted the experiments and exposed the device into several conditions. So one is the simulated test of the device. So here, data show that the panel automatically closes the moment the sensors detected that the light sensors is not present. Now, moving the light source momentarily results in a jiggly to steady movement from the device and the panel. So you can see here that we are testing the device, whether it conforms to our design that with a switching mechanism that if it follows the location of the sun or if it turns off when there is no light detected and so on and so forth. So this is just a simulation, which is the one that I mentioned earlier. So now uh, we are now looking at the actual environment test of the device, in which the device is exposed to the real world situation. Now, the results show that the sensors are working perfectly. So the panel started tracking the exact source of light starting from 8 a.m. until noon, where it is directly parallel to the sky as the sun approaches zenith. The sun then moves to the horizon for sunset, and panel started to repeat the same position at 8 a.m. but the opposite side. Now, we replicate this experiment multiple times in order for us to achieve several conditions and information that we recorded. So within these trials, the device fortunately was able to perfectly work and was able to follow the uh, location of the sun. And you can see the small thing here that is beside the Respus is the fixed mounted solar panels, in which this is one of the control parts of the experiment in which we also recorded its information that is present there. So this fixed mount solar panel does not move versus our device, the Respus. The next one is the wind tunnel simulation test, which is the that is mentioned earlier. So here you can see this. You can see from the table 1 of our paper, 200, from table 2071 of NSCP 2010 6th edition. So the basic wind zone for Albay province is at most 250 kilometers per hour. Now, the computed pressure for the simulation is at least 46 uh, PSI. And results showed that the device is capable of withstanding 250 kilometers per hour wind velocity equal to a typhoon. So in this wind tunnel, so that we simulated, we place the device on the other end of the tunnel. Then on the other side, we use an air compressor that provides the sufficient amount of air with the velocities are reaching 250 kilometers per hour and subjected our device to be hit by that such amount of wind force. Fortunately, the device, because of its design, was able to withstand those extremely harsh wind condition and was able to become intact, undamaged, and there is no parts that is missing or is destroyed. Fortunately, the device passed the test and was able to conform with standards uh, which relates to typhoons and similar situations that involves such amount of 250 kilometers per hour of force of wind and 46 psi. So you can see here the working of the device, simulation of the device. So you can see here we used a flashlight to replicate the movement of the sun, and you can see here that it is working perfectly following the location of the light. So you can see here. So another one, this is the actual testing of the device. So that is the
So for the results, so after the experiments, we got the average current or gained through three trials for panel A and the device panel B, and it is evident therefore that the optimum amount of light is in between 11 a.m. and 12 p.m. with the panels gaining 0.063333 amperes and 0.10333 ampere respectively. So the weather was clear with little to no clouds. The results of the test showed that the device with the solar tracking mechanism can harness more energy and is more efficient than a mounted panel at any time of the day. It also illustrates the significance of tracking the solar azimuth where the amount of current harnessed is at most quantity. So based on this chart, the 12, 11 a.m. and 12 p.m. is the best time to harness the the amount of sun, and it is shown that if we have a solar tracking mechanism, we can directly get all of it. So so for this one, net current harnessed by the device versus the amount harnessed by panel B. So we can see that our device uh, so So after getting into three trials, the setup was on a real environment setting. It was put on a flat surface that had the presence of the sun. So for this, we subtracted the net output current of the of the device to the Arduino. So overall, our device net current. So the experiment harnessed by the device versus the amount of harnessed by panel B. So calculating for the amount of current by subtracting the amount of current consumed by the Arduino from the amount of current harnessed from the sun by the device gives us an insight whether the device is self-sustaining or not. Results show that the device produces more energy than the amount it consumes. Panel A could harness more current than device than when the current consumed by the Arduino is subtracted. However, comparing the amount of current harnessed by the device and panel A without taking into account the current consumed of the Arduino tracking system, it significantly shows that it produces more and consistent current than the fixed panel. So even though we got lower amperes after subtracting the amount of current consumed by Arduino, it is shown that it is still the result is still efficient than the usual fixed mounted solar panel. So next. So for the two-way ANOVA. A two-way ANOVA was performed to determine the effect of the time and angle of the sun from 8 a.m. to 9 a.m. to 3 p.m. to 4 p.m. and the movement, stationary moving of the panel on the current harnessed by panel A and panel B. So we use the two-way ANOVA and with three replications. So based on the result, for factor A, the relationship of the averages of time group. So from 8 a.m. to 4 p.m. So here we can analyze that HO, which is the the null hypothesis. There is no significant difference between the performance of stationary panel A and moving panel B. So H1, there is a significant difference between the performance of stationary panel A and the moving panel B. Since the p-value is less than the less than A, HO or null hypothesis is rejected. All time group averages are considered to be not equal. In other words, the differences between the average of time groups is big enough to be statistically significant. So this means that the time group has a significant effect to the current harnessed by the panel A and panel B. Panel B is our device. Then panel A is our fixed mount solar panel, which is our control. So for factor B, this is the average of movement group. So it's for the moving and stationary. So panel A and panel B. So the null hypothesis is there is no significant difference between the current harness in terms of time and the angle of the sun. Each one or alternative is there is a significant difference between the current harness in terms of time and the angle of the sun. So since the p-value is less than A, HO is rejected. Movement group averages are considered to be not equal. In other words, the difference between the averages of movement groups is big enough to be statistically significant. So this means that the movement of panel B, which is our device, affected the current harnessed by our device. So for the interaction of A and B, it is to determine if time groups 8 a.m. to 4 p.m. and the moving or stationary panels are or if they are connected to each other. So for HO, the effect of the angle and time does not depend on the effect of the movement of the panel. So for H1 alternative, the effect of the angle and time depends on the effect of the movement of the panel 1. So since the p-value is greater than A, HO cannot be rejected. The averages of all groups are assumed to be equal. In other words, the difference between the averages of all groups is not big enough to be statistically significant. A non-significance result cannot prove that HO or the null is correct, only that the null assumption cannot be rejected. So this proves that the movement of the device would only rely on the presence of sunlight and not with the time. So, based on this data, results of the experiment show that there is a direct relationship in terms of utilizing the presence of the sun and developing a certain mechanism that mimics or replicates the natural movement of the plant, which is called the phototropism. By definition, it is the ability of plant to create movements in accordance with the sun's location, and in addition, this allows the researcher to develop a conclusion that enables them to develop a mechanism that allows stress to start itself when there is no light present. So next. So for the seat, okay.
For the safety, so the design of the Typhoon resilient and self-storing phototrophic solar panel system adhere to the electrical safety code from the Philippine Electrical Code. So these are the articles. Articles 1.0.18 about wiring planning. It states that the number of wires and circuits confined in a single enclosure be varyingly restricted. Limiting the number of circuits in a single enclosure will minimize the effects from a short circuit or ground fault in one circuit. Next is about the service equipment. It states that enclosed or guarded that the device should be enclosed or guarded. Energized parts shall be enclosed so that they will not be exposed to accidental contact or it shall be guarded. And Article 2.4.3.1a, protection from physical damage, it states that overcurrent devices shall be protected from physical damage. For the cost benefit analysis,
The payback period of 30 years is not acceptable as the average expectancy of a solar panel system uh, uh, of a solar panel is 25 to 30 years. This means that the consumer will not be able to make up with the cost of the device without scaling into a bigger solar panel.
So for the conclusion, so we created various conclusions based on the problems that we established within the start of this study. So one of the conclusions are: one, the design of the device focuses on a very compact box design structure which enabled it to withstand multiple simulated weather conditions such as typhoon. Another conclusion that we are able to find out is that comparing the amount of current harnessed by the device and panel A without taking into account the current consumed by the Arduino or solar tracking system, it significantly shows that it produces more and consistent current than the fixed panels, leading us into a conclusion that the device is self-sustaining and in addition produces extra amount of current to charge the battery as well. And another conclusion is the device conforms to basic safety standards such as design structure, electrical, and mechanical safety standards for moving parts. Another one is that the payback period of 30 years is not acceptable as the average life expectancy of a solar panel is 25 to 30 years. This means that the consumer will not be able to make up with the cost of the device without scaling to a bigger solar panel. This means that since we develop a device with a smaller area of solar panels, it would be much more beneficial to buy or invest into ones with bigger solar panels in order to achieve maximum efficiency, maximum amount of energy harness, and maximum amount of savings they can derive from using one with bigger panels, but with the same mechanism as Trespass. And for our recommendations, so these recommendations aims to solve the certain problems encountered within the development of our study or our device Trespass. So one of the number one recommendation that we would want to consider the other researchers to do so is to increase the area of the panels. To increase the area of the panels used in the device, as the results showed that increasing the area would significantly improve the amount of current harnessed by the device as the current consumed by the Arduino stays the same. Since our device uses a small area of panels, this is just sufficient for the device to sustain itself and grant an extra charge to the batteries. So this makes the Trespass self-sustainable. So it works just by harnessing energy from the sun. However, since it uses small area of panel, that is that is only a very small amount when we try to think of it. But if we are going to increase the area of the panels, we are going and we would be able to harness much more energy, and at the same time able to self-sustain the device without any more problems. And this would mean that increasing the area of the panels used in the device would also be more cost effective and much more efficient to use. The other one is to make it more compact. Why? Because to adjust the design of the device in order to make it more compact as the design by the researchers is a prototype at its simplest form. It is evident on the device from the previous images that we've shown below that it is not that much compact. There are some parts of the device that are exposed, such as wires. Also, upon creating the device, uh, there are some small gaps within the device. That is because the device is not that perfect, and at the same time, it is just printed. However, when we try to refabricate it into a new design that involves several materials such as steel, plastic, and other strength type materials, we are able to furtherly improve the efficiency, the effectiveness, the strength, and the survivability of the device, uh, which would lead to consumers saving more and earning more of the energy provided by our sun. And for another one is to utilize the materials such as steel, metal, and etc., which is the ones that I mentioned before. So by utilizing these materials that conforms to building and structural standards set by the government for bigger panels for mass production. So of course, although these panels, 3D printed panels, are relatively cheap, it is much more efficient to purchase or develop ones that is made by government or government government you call that government rules and regulations that conforms to building and structural codes. So since these types of devices are exposed to the environment, they need to be made with some materials, with most materials that are more effective in surviving those weather conditions, such as steel or other materials that are present in our market. At the same time, by utilizing these materials, it would also improve the life expectancy of our device and at the same time protect the device from wearing and tear. Next one is to record the voltage fluctuations. Why? So to record the fluctuations in voltage produced by the device to generate more accurate and more coherent result. So this is because what we recorded in our experiments are just the current. We did not record the changes in voltage because we used a charging module which is called TP4056. This type of module, which is connected to our device, makes the device be able to produce a consistent voltage amount of 5 volts. So that means that regardless of the voltage produced by the panels, the module would supply the battery charge of 5 volts and with only varying amount of current entering the battery. So this consistent 5 volts protects the battery from from overcharging and from malfunctioning. So 5 volts is the standards used by most USB devices, which is the standard we use in our device in order to conform to this safety standards in order to charge safely our battery. So that is the reason why we would like to recommend to record also the voltage fluctuations using similar or different uh, methods. So here are some of the reference that is present in our study. So that ends our presentation for the Typhoon resilient, self-restoring, solar tracking, uh, solar panel system or trespass. And again, I am Castel V.
And Latrell Cimanes.
Christian Bonto.
Christine Borlagdan.
And Charilo M. Olaguera.
Thank you for listening, and let us meet together on the next episode of our presentation. Good evening and God bless us all.
Sabihin yung question kung meron. But please send me
But the questions of the panelists, uh, we would like to ask the panelists to send us the send us your feedbacks, reactions, and your questions, which revolves around our study, in order for us to determine what are the things we need in order to improve it, or what are the things we need in order to change and conform to our standards. So that's all for today's video.